Hello, Marauders, and welcome back. I'm out here surfing, having a good time, and I seem to have picked up a stingray. Let's get him out of here. But we're going to do chapter 6. It's one of the most confusing chapters, but we're going to cut it down just to the basic things you need to know. Because some of the questions would be like entire projects to figure out. So let's just get through the basic ideas. It's called polar coordinates. And there's sea lions and everything around me here. So let's get to the work. Okay, so this is section 6.3. It's called polar coordinates or polar graph paper. We're used to the regular graph paper called rectangular, regular graph paper. And I have it because it's X and Y, kind of looks like a rectangle. And when you name a point, you name X, comma, Y. Like if there's a point here, you'd be like 1, 2, 3, 4, maybe up 1, 2, 3, and you say, oh, there's 4, 3. But sometimes we like to use a different graph paper called polar graph paper. Yeah, that's it. Looks kind of like a target. Imagine you're at the North Pole looking down on the Earth, or like a radar screen. It's round. It's based on the unit circle. It's kind of like using this as graph paper. So it looks a little complicated, but it's not. Here's how polar graph paper works. You do have this, but instead of having X and Y, you're going to have two things. You're going to have the radius and the angle, or we're going to say R and theta. So the first thing, the radius, imagine you're at the center, like here you are, and there's like an airplane coming at you, and you say, look at the airplane, and your friend says, where's the airplane? And you're like, over there, and like, where over there? You say, well, how far is the plane? So what we have is these circles. This could be 1, and this could be 2. Think of like a radar screen or a target or like a bullseye or a scope. And this is 3. So if we saw a plane like over here, and there's a plane up in the sky, or appears in your radar, you'd say, well, it's 1, 2, 3, like 3 miles from me. It's off in this direction. It's 3 miles away, so you're going to say it's at 3, and then you say the angle. And of course, you could use a protractor, but we won't make it difficult on you. Remember, we always start 0 over here, and just like your unit circle, as you go up, you'd say what this is. And of course, I'd have to be a little nice and tell you what this is, but let's say this is 45 degrees to line up with this. So you'd say 3, 45 degrees. Sometimes they do it in radians and say pi over 4, because I remember on my unit circle, here's pi over 4. So you're going to kind of say the angle that the point is at as you go up all the way around, and you're going to say the distance. So it's actually not too complicated. It's kind of fun. So let's look at this little piece of graph paper. And even like on a graphing calculator or Desmos, you can put it in polar system. So let's put a point on here. If I put a point like right here, and I say name that point, and it's hard to read this, 1, 2, 3, you'd say, well, it's at 3 is the radius. I was going to use the radius, then the angle. And you say the angle is, well, oh, somebody wrote pi over 6. Or you could say 30 degrees. Okay, let's try another dot. Let's try one way over here. Okay, so I would say, oh, let's see, that's 1, 2, 3. It's 4 miles away. Here comes a UFO. And here I am at the center. And it's 4 miles away. So this point over here is 4. And the angle, well, 7 pi over 6. Or 210 degrees. See, that's not too hard. Okay, next thing is sometimes we can name these more than one way. Remember my point 3, 30 degrees? Well, that's if we went up like this. But remember that thing where you did coterminal? What if you decided to go all the way around? You could actually sit here and add 360 to it and say, well, it could have been 3, 390 degrees. Yeah, you could say that. Or it could have been going backwards, going this way, all the way backwards and say, okay, let's see, subtract 360, negative 330. So remember, positives going this way, negatives going that way. So they might be kind of funny and say it's at 3, negative 330. Here's something else that's kind of interesting. Okay, so here's a polar coordinate, 2, 80. So just remember r and theta. So if I said graph this, you're like 2, okay, 1, 2, 1, 2, that's the distance. 80 degrees, well, 90's up here. So 80's about, how far? About right there. There's 2, 80. But sometimes they'll do something funny. They'll say, how about negative 2? How about 40 degrees? You know, negative 2, yeah, they say the radius is negative. In other words, you go backwards. It's kind of funny. Well, how do you do negative 2 radius? I don't get it. Okay, so let's find 40 degrees. Okay, so going upward, 40 is about there, right? About here. But wait a minute. Instead of going this way, positive 2 radius, 40 degrees, they want you to do negative radius. So what you do is you go the opposite direction. Don't go this way. Go backwards. This way. So instead of going 2 radius, negative means go reverse. And this is where the dot is. Negative 2. Instead of going forward, back it up. That's negative 240. Could you name this another way? Sure. Here's another way to name it. I could say, well, what if I got here just by going all the way around and said, what? Can I just call it positive 2? Yeah, but what's the angle now? Here's the trick. You're 40 degrees. This was 40 degrees past. So this is 40 degrees past. Quick way, just add 180 is a way to get to the opposite side. That says plus 180. So 40 and 180 is 220. Let me write that bigger, 220. So this is the same point. So they're going to give you some stuff. Try to name the points in different ways. You're going to have a little challenge at doing this. I'll show you something from the book. Here's some pictures. It's on 6-3. Here's 2, 135. 2 is the distance, and they went 135. There's the dot. You don't have to draw the line, just the dot. And then this one, negative 3, 3 pi over 2. Okay, the radius is 3, but first of all, they said, where is 3 pi over 2? In case you forget, 3 pi over 2 is down here. That's 270. 3 pi over 2. Now, how come they didn't put a dot down here? Because they said, be backwards, opposite day, negative 3. So they went all the way around, about to put a dot. Oh, reverse it, flip it over here. That's where you put your dot. One last one. Here's a weird one. Negative 1. Okay, negative pi over 4. Okay, we're going to go backwards. Pi over 4. Pi over 4. Or pi over 4 is like 45 degrees, but you're going to go a negative angle. Instead of going the normal direction, you're going to reverse it, going on this way. And before you put your dot, you're about to put your dot right there on 1. You're like, oh, wait, negative 1. Whoop, to the opposite side. Okay, so a little challenging. But they're kind of fun to do. Okay, and here on this screen, I put what is a quick way? What is a quick way to go the opposite side of a circle? What if you were in radians and you're like, okay, here's this, and you're about to go over here, but they did negative radius. You're like, well, I have to go over here. You could just look at your unit circle. That works pretty good. But a quick way, you can't really add 180 degrees. Well, I would, but except somebody did in radians. So let's add pi. If you add pi with pi over 6, you get 7 pi over 6. Because isn't 7 pi over 6 like 6 pi over 6 plus 1 pi over 6? 6 and 1 is 7. So a quick way to go opposite, if you were here and you want to go the opposite, you could just add pi, or if it's too big, you could subtract pi. So it's a way to get to the opposite side. If it's in degrees, it's easier just to add 180 or maybe subtract 180. Turn the page. Okay, so 3 more ways. It says find 3 more ways to name this. So first of all, let's find pi over 4, and 5 is a radius. So I'm going to be going outward. I'll do it in black here. 1, 2, 3, 4, 5. I tried to make a dot. It didn't work out too well. There's a dot. Okay, that's supposed to be my dot. There's a good dot. That's pi over 4 and 5. But what if they said, give me an angle that's even bigger? Well, just add 2 pi to it. And you would kind of go, well, let's see, 2 pi and that. This is like 8 pi over 4. This would be 9 pi over 4 as my angle. It would still be 5. 5 comma 9 pi over 4. Sorry, it's such a mess on here. And I can't really write on here. It doesn't work. Okay, so let's say you've got this, and they say name it multiple ways. First of all, let me draw it. 1, 2, 3, 4, 5 pi over 4. Okay, because pi over 4 is there. It doesn't hurt to get out your unit circle and kind of go pi over 4, about 45 degrees. Can you name it some other ways? Sure. Instead of just going right there, what if you went all the way around and got there? So, multiple ways to do it. Take your original thing, take your original answer, just add 2 pi to it. If you just take this and add or subtract 2 pi and get there. So if I want to add 2 pi, let's see, 2 pi. How about call it 8 pi over 4, because he's got a 4. 8 plus 1 is 9 pi over 4. So 8 and 1, 8 pi plus pi over 4, 8 and 1 is 9 pi over 4. So this is another way to say it. Or if you decide to like, hey, I want to go backwards, go in the backward direction. I could call 5 negative. Well, what is that? Here's a quick way. Instead of subtracting 2 pi over 4, why don't I just kind of go, well, that's kind of like this. If I went around backwards, that's 7 pi over 4. I know I explained that short, but if you went backwards, imagine you had pi over 4 and subtracted 8 pi over 4. 1 minus 8, negative 7 pi over 4. But sometimes they even say, hey, let's try the negative angle. Or not negative angle, negative radius. How would I do that? Well, if I was here, negative would be over here. What was this point here? Well, if I went all the way over here, that's, well, this is about 45 degrees. Pi over 4 is 45. I looked at this and just kind of went opposite. 5 pi over 4. Or, yeah, I'll just go 5 pi over 4. That's the easiest way. Or I could take this guy and just add pi to him. In fact, how do I add pi? How about 4 pi over 4? 1 and 4 is 5. So multiple ways to name this point, because this point here, if you went to 5 pi over 4, but then did negative radius, you're back where you started. So all these are the same thing. Okay, one of the other things you need to do is sometimes we like to be able to go from one system to the other. In other words, what if I gave you polar coordinates and said, could you turn them into XY coordinates? Or if I gave you XYs, could you turn them into polar coordinates? There's actually a button on your calculator that does this change, but it's kind of hard to use. So let me show you how this works. Okay, so let's say I gave you something like 3, 30 degrees. And the idea is, of course, this is on polar, but what if I put a piece of regular graph paper right on top of it? Could you switch from one to the other? And yeah, it seems kind of confusing, but there's some tricks. And first of all, let me put the point on here. The radius is 3, so 1, 2, 3, and 30 degrees, about right there. 3, 30. But were you wondering, what if this was regular graph paper? Boom, 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 boom. Could you figure out what this is as X and Y? Okay, so in the book, there's this little chart. Okay, and there's 4 little rules. All of them are based on the Pythagorean theorem. You've actually seen all these before. And the switch, there's these 4 rules. That's a Pythagorean theorem. There's tangent. We've seen that before. We've seen these rules on our sheet. You know, we got tangent. We've got, and these other ones, x is r cosine. That's really right in here. If you remember, cosine is this. Instead of the radius being 1, what if it were r? And you just kind of cross multiply. I also got them right here. I know it's a brief explanation, but this is just the Pythagorean theorem. This is tangent. And this, x and r, x is r cosine, y is r sine. Okay, let me move this out of the way. Okay, so here's what we're going to do. You would like to know x. So the way to find x is we got polar to rectangle. It says r cosine theta. So x is r times the cosine of theta. How did they come up with this? Well, you know, as a little side note, if you're wondering, where did they come up with this? What if I divided by r? X over r is cosine of theta. Well, yeah, remember on a piece of graph paper, here's x, here's y, here's r. Isn't cosine the adjacent over the hypotenuse? Cosine's the adjacent over the hypotenuse, x over r. Well, what if you just cross multiply that? Then x is r cosine theta. Okay, so what do we do? Well, to find x, we're going to take r, which is 3, and we'll do the cosine of the angle, which is 30. And you could either put down a calculator or we'll just look it up. They give you one so you don't have to pull the calculator out. The cosine of 30, we just look this up. In fact, we can look down here. Cosine of 30 is radical 3 over 2. Or you could go cosine is the x, radical 3 over 2. And you say, so well, 3 times that would be 3 radical 3 over 2. Now, let's do it for the y. So that's x. Let's do y. Y is, I gotta zoom out here so we can see what's going on, r sine theta, because remember y is the sine, so you just take r, 3, sine of 30, and so go 3, and sine of 30, look him up, he's 1/2, 3 times a half is 3/2, and ta-da, you did it. So if somebody gives you polar, it says rectangular, you're just gonna go, okay, I'll just do the radius times the cosine of the angle, that's the x, and radius times the sine, that's the y. That's the brief explanation. You're in class and get a little better into it. Okay, so let's just see, like here's a book example in the book. They have this one and this one, and they say, okay, can you change them from polar to rectangular? And why don't we try this one, -8 pi over 3. Okay, so we have -8 pi over 3. Remember, this is r, this is theta. And so they would say, could you change this polar guy, polar, to xy, which is rectangular? Like I say, some of you can find a button on your calculator that does it. It is here, but it's difficult to use, so I never bothered. There's like polar, rectangular. Some of you actually see it look like I wrote on the paper. But let's see, how do I do it? Oh yeah, I just look at my 2 rules. They're there in the blue box. We're right here in the yellow box. There they are, polar rectangle. Okay, so let's see, I need x and y. This is x is r cosine theta. Y is r sine theta. So we'll go x is r, -8, who cares? Doesn't scare me. Cosine of pi over 3. Y is -8, and here's theta, sine of pi over 3. So x is -8, cosine of pi over 3. Of course, if you don't have it memorized, you feel free to look it up. Cosine of pi over 3, 1/2. And let's multiply. -8 times 1/2 is -4. There's your x coordinate. And -8 times sine of pi over 3 is radical 3 over 2. And so that'd be -8 over 2. Wait, could you cancel here? You cancel. -4 radical 3. That's the y coordinate. And so write your final answer, -4 comma -4 radical 3. Ta-da! I did it. Okay, last thing we're going to do. Okay, so they give me some rectangular coordinates, like 1 comma radical 3. Okay, imagine you're on graph paper. Let's see, boom, 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 boom. 1, radical 3 is a little bigger than 1. And somewhere around here on graph paper, this is x and this is y. But they want to know, okay, so what radius is this thing, you know? And what angle is that? Oh man, how am I going to do this? So we're going to use the other 2 rules. They're right here. It looks a little confusing, but this is the Pythagorean theorem. And this is the tangent. Okay, so here's our 2 rules. So Imagine, let's draw this triangle a little bit bigger. It's in quadrant 1 because this is positive. Here's the angle. So if this point is 1 radical 3, and that's x and that's y, isn't this over 1 and then y up radical 3? Over 1, x is 1, up radical 3, y is radical 3. And what do we want? We want r and theta. So remember, here's the graph paper like this. I did in quadrant 1 because these are positive. So what is this angle and how long is this piece? But this is the radius. That's the hypotenuse. So you're just going to do the Pythagorean theorem because the radius is the hypotenuse. Okay, so to get this, that's the Pythagorean theorem. So let's see, we're going to go 1 squared plus radical 3 squared. And that's r squared. So let's see, 1 squared is 1. A square cancels the radicals. 3. 1 plus 3 is 4. What squared is 4? Okay, square root. R is 2. Should I go plus or minus 2? No. We just want the positive radius. So I got the radius is 2. That's why on your sheet it says x squared plus y squared and saying take the square root. Plus or minus, just in case somehow you were doing a backward angle or something. Okay, so we got that. Now we need the angle. Oh, wait, that's basic SOHCAHTOA. What is the angle? I need to find the angle. How about I just say, well, the tangent of the angle, and I'm just going to use the rule right here. The tangent is the opposite, y over x, the opposite, radical 3 over 1. Well, what angle is that? I could pull out my calculator and go second tangent, radical 3 over 1. In fact, I could do that right now. I could go second tangent, but then I think radical 3 divided by 1 and go, okay, what is this? It says 60. I'm in degrees, 60 degrees. Or maybe I should just look it up on my sheet. Tangent of radical 3 over 1. Let's try to find it. Find it on this list. Notice they give you numbers that you can look up. Radical 3 over 1. Where radical 3 over 1 is radical 3. Oh, there it is. Radical 3, 60 degrees. Now, how come I don't pick this one? 240. Well, which quadrant am I in? I gave you positives. You're in quadrant 1. So we're going to use, what do we say there? 60 degrees. 60 degrees. So we went backwards. All right. I'll do one more with you. Okay, here's our last one. Here's some XY coordinate. And first of all, I should graph it. Let's see, positive, this is X, this is Y, positive over 3 radical 2, and then negative down 3 radical 2. Draw this guy out. There you go. And think about this point. There's your point, 3 radical 2, negative 3 radical 2. Okay, let's find these goodies. Let's find the radius. Here's the radius. The radius is the hypotenuse. Okay, let's do Pythagorean theorem. Let's do this squared plus this squared, right? That's x squared plus y squared. Let's do 3 radical 2 squared plus negative 3 radical 2 squared. And then, of course, we have the square root. Don't get scared here. Square the 3, 9. Now square this, and this will cancel that. So that's just a 2, so we have 18. Now we do it again. The 3 squared on the negative times negative is positive. It's getting squared. So 9, 2 cancels the radical. So 2, radical 2 squared is 2 is 18. 18 and 18 is 36, and square root 6. Oh, okay. 6 is a radius. See, that's not so bad. And oh, we got to do the angle. What is this angle here? So let's do the tangent. Because we always do the tangent. It says I have the x and y. Remember, our sheet just says just do the tangent. So the tangent is the opposite, negative radical 3 over 2, over the adjacent, 3 radical 2. Or some people just think of it as, another thing is tangent as y over x. And so we have the tangent is, check that out, -1. What is the tangent -1? So I grab my sheet, or I could just use my calculator and go second tangent, -1. 135. Wait a minute, 135? Does this look like I'm at 135? Which quadrant am I in? Uh-oh, let's keep going. I should go around the other way. -1. 315. -1. 315. That sounds, this looks like 315 degrees. So 315 degrees. Or you could write in radians if you want. Ta-da! That's what we got. One of the things we won't be doing because of time is solving polar equations. Yeah, these are polar equations. Instead of x and y, they have r. Oops, you can't see that. They have r, like r and theta. These are kind of weird looking equations. And how would you solve them? Well, if we were in class, we would solve these things and figure out how you can turn like a polar equation into a rectangular equation or vice versa. Fortunately, I'm not going to try to like drive you crazy here doing distance learning, and we'll leave it at that. I think we're good. So why don't you try the homework I gave you? I shortened it up. Then check your answers. You don't have to do all the stuff because I have my homework shows all the answers, but go ahead and do that. Okay, so remember, the homework 6.3, instead of going all the way to 71, just go to 47 odd, because these ones are equations. And skip 39, just because you'd have to pull a calculator out to do it. But you can do it if you want. And some of this is just matching. This is graphing the dots. And sometimes there's multiple ways. But either way, look at the book examples. Look at my homework. I go through it. You get 2 days, not due till Wednesday. When you're done, take a photo of it. If you wanted to do equations, you could read into this, but like I say, if we're in class, it would be easy to learn, but trying to explain it online can be a little confusing. So just go only up to 47. All right, and the next 2 sections, we're going to do even just a little bit of them. This is the main section that you need to know for Friday's test. All right, goodbye, Marauders.